Let us have one example. This is very important example because many of the analog to digital converters or digital to analog converters, they use uniform quantization. In uniform quantization, you get your real number, and then the distance between these regions, they are this guy is equal to this guy is equal to this guy, and so on. So you start at some point and you end up at some other points. So let's say this is A1, A2, and so on. So they are all equally distanced. And the quantization levels are in the middle of each of these. So this is, let's say, if this is A1, so let's say this is X2, because X1 is somewhere in the first interval. And let's say if this is N minus 1, this is and this is N minus 2, and so on. So this is, then the next one is X3. So X2 is equal to A2 plus A1 divided by 2. So it's in the midpoint of each partition. This is like an 8-level uniform quantizer. So you see that the distance between these two guys, this one and this one, is delta. The distance between these and these is delta, and so on. And also the distance between these guys is delta. So you have delta, 2 delta, 3 delta, minus delta, minus 2 delta, etc. So we call it mid-thread because 0 is like here. And it's symmetrical, so you have 3 delta and you have 7 levels. If you want to have 8 levels, then you will have a shape that comes here. So let us have just one example. Suppose that this is my continuous time signal. The first step is to take samples. So at minus 5 TS, I get this value. At minus 4 TS, I get this value. At minus 3 TS, I get this value, which is 0. Minus 2, I get this value. At minus TS, I get this value. At 0, I get this value. At TS, I get these. So these are my samples, which are determined by circles. Now, the value here, these are my quantized value. Either I'm at delta, 2 delta, 3 delta, 4 delta, 5 delta. So this sample is closest to what? Is closest, let's say I draw this line here, is closest to 2 delta. So if I quantize it, so these will be mapped here. This sample is closer to 2 delta, so these will be mapped to here. This sample is close to 0, it will be mapped to 0. This sample is closer to 3 delta, I will quantize it to here. This sample is close to 4 delta, will be mapped here. This sample is close to 5 delta, I map it here. This sample I map it to 5. This sample I map it to 4 delta, is very close. This sample is close to 2 delta, I map it here, you see. And 4 TS, I map it to 4 delta, 5 TS, I'll also map it here. So I have this is my quantized value here, this is my quantized value here, this is my quantized value here, my quantized value here, 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 I get it here, I got it here, here, and here, and here. So one way to reconstruct your signal is, okay, my quantized value become constant, I just hold the value, I just hold this value, hold this value, always hold on your values, okay. Of course you can do better than that, but this is just one simple way. So this is the signal which is first sampled and then it is quantized. If you have more levels here, these errors will be reduced.